Let us imagine, very gently, that our planet is not only a stage for the stories we already know, but also for stories erased so thoroughly that only silence remains. What if, long before the great age of dinosaurs, there had been other kinds of builders, other forms of intelligence, working and living in ways we cannot easily picture? It is not a claim, only a soft wondering, like pausing before a quiet horizon and asking what lies beyond. The Earth is ancient beyond our ordinary sense of time. When we say billions of years, the numbers slip from our grasp. A billion years is not just long. It is a depth where mountains rise and vanish, oceans open and close, continents drift like slow rafts. Within such expanses, entire histories could play out and dissolve, leaving almost nothing behind. To hold this thought, we need to slow ourselves, to stretch our view from the narrow human scale into the wide measure of deep time. Deep time is a term scientists use to speak of the planet's vast age. Imagine a calendar where one page stands for 1,000 years. Even a heavy library filled with those pages would cover only a small part of Earth's true span. Against this backdrop, the few thousand years of our recorded history are just a corner of a single sheet. When we place our tiny presence within this longer rhythm, it becomes easier to imagine that other chapters might have existed and then been erased. Now we may pause for a moment with the way traces survive. Almost everything we make, no matter how strong it seems, is fragile across millions of years. Stone crumbles, metals corrode, glass softens back to grains of sand. If we left a modern city untouched, in just a few tens of thousands of years, it would vanish under soil, roots, and shifting ground. Multiply that by hundreds of millions of years, and silence grows deeper still. The record of the Earth does not hold everything. It is selective, almost careless. Fossils, for example, are rare. Most living beings do not become fossils. Conditions must be just right: quick burial, absence of oxygen, pressure, and minerals at the proper balance. The same is true for traces of culture or technology. Only under unusual circumstances could they endure. This means that the absence of evidence cannot be read as the evidence of absence. The Earth remembers only in fragments. Scientists often speak of this memory as an archive, stored in rocks, in sediments, in chemical layers. But this archive is incomplete, like a diary with most pages torn out. Within the remaining scraps, we learn to read carefully, aware of what might be missing. Now let us think slowly about what kind of marks an ancient civilization, if it had ever existed, might leave. Not towering buildings or statues, for those would fade. But perhaps chemical shifts, odd minerals, unusual isotopes in the layers of stone. These are like fingerprints blurred by rain. They do not reveal a clear image, but they hint at something out of place. We might imagine an ancient industry altering the carbon balance of the air, much as we do today. Over millions of years, the gases would settle into sediments, forming subtle stripes in the archive of rock. If we look back and see such stripes, we must ask, are they natural or are they something else? Science approaches these questions carefully, never rushing, never certain without support. To feel the scale, let us follow a short thought experiment. Imagine first a civilization arising 300 million years ago, when vast swamp forests covered the land. Imagine it flourishing for a few 100,000 years, then vanishing. Over time, its cities collapse, its tools corrode, its traces scatter. Millions of years pass. The swamps turn into coal, the continents drift. Almost every sign disappears. Now imagine, second, that only a tiny fragment of its activity lingers, perhaps a chemical oddity locked in a layer of stone. Millions more years pass. Dinosaurs rise and fall, mammals emerge, and eventually we appear. We drill into the stone, and there, faintly, the fragment waits. We hold it up, uncertain, and wonder what it means. Finally, imagine a third step. We cannot decide. The signal could be
geological,
Or it could be something else. Science does not leap to conclusions. It keeps the door open, patient, humble. This is where we stand, surrounded by silence, holding a few uncertain clues. When we reflect in this way, the point is not to prove or disprove. It is to expand the horizon of our thought, to recognize the immense scales of time, and to accept how little survives from the distant past. Perhaps nothing existed before dinosaurs beyond the life we already know. Or perhaps something did, erased almost completely by the patient hands of erosion, tectonics, and time. We cannot be sure. And so we rest in a quiet balance, not in answers, but in perspective, letting the thought settle softly, like dust on an old page. When we speak of time in everyday life, we usually think of days and years, sometimes decades, perhaps centuries. These are scales we can hold in memory, connected to seasons, generations, or familiar history. But the Earth itself does not move in such brief rhythms. It follows deeper patterns, measured not in thousands, but in millions and billions of years. Scientists call this perspective deep time. To imagine deep time is to stretch our sense of duration far beyond the reach of ordinary thought. It is like standing on a beach and looking not at the nearest wave, nor even at the tide of a single day, but at the slow carving of the shoreline across entire ages. In this view, mountains are not eternal, but temporary. Rivers do not merely flow, but slowly redraw the map, and continents drift as though they were rafts on a patient ocean of stone. Now we may pause for a moment with numbers, not to overwhelm, but to gain a gentle sense of scale. Our planet is about 4.5 billion years old. The first simple life appeared more than 3 billion years ago. Dinosaurs arose about 230 million years ago and vanished 65 million years ago. Our own species has existed for only a few 100,000 years, with civilization just a fraction of that. On this timeline, the human story is no more than the thinnest scratch at the very end of a long scroll. Within such immensity, the idea of civilizations before the dinosaurs becomes less implausible to contemplate, not because we have evidence, but because the canvas is so wide. To grasp deep time, we often rely on metaphors. One way is to imagine Earth's history as a single day. Life begins before dawn. Complex animals appear only in the evening. Dinosaurs come late at night, and humans arrive in the final seconds before midnight. Another way is to picture a library, with each book standing for 10 million years. In such a library, the chapters of human history would not fill even a page. These metaphors help us feel, if only faintly, how much could happen in spans far larger than our own. But deep time is not only vast, it is also selective in what it preserves. Much of the Earth's surface is restless. Rocks melt and reform, oceans open and close, mountains rise and crumble. This means that only fragments of the past survive, stored in layers of stone, in tiny fossils, in chemical residues. The deeper we look, the fewer traces remain. In this way, the record of deep time is both generous and incomplete. It tells us much, but it also leaves wide silences. Now we may pause with the language of those traces. Geologists study strata, which are layers of rock laid down over time, like pages stacked one on another. Within them lie fossils, minerals, isotopes, tiny clues about what the Earth was like when each layer was formed. Carbon ratios reveal ancient climates. Volcanic ash shows sudden upheavals, and even the absence of certain signals tells us something about changes long past. To think of civilizations in such a context is to ask whether any unusual patterns might appear in these archives, patterns not easily explained by natural processes. Until now, none have been found. But the absence of evidence is not evidence of absence. The Earth's memory is partial, and much has been erased. Let us now try a soft thought experiment. Imagine that somewhere in the depths of time, a form of intelligence arose. Imagine it lasting a few 100,000 years, then fading. Its traces would settle into soil, rivers, and oceans. Over millions of years, continents would shift, Mountains would rise, glaciers would grind. Almost every artifact would vanish. Perhaps a few chemical anomalies would remain, a slight shift in a layer of carbon, an unusual mineral concentration. Later, as millions more years passed, these fragments might themselves be buried deeper, scattered thinner, until only the faintest hint was left. And now we return to our present, where scientists search patiently through rock and ice, finding occasional oddities. Most explained by natural processes, some left uncertain. We cannot know if those uncertain ones are echoes of forgotten civilizations or simply quirks of geology. What we can know is that deep time allows room for the imagination, even while evidence remains scarce. From this thought, a quiet conclusion emerges. Deep time does not tell us that other civilizations existed, nor that they did not. It reminds us instead of the vastness of the Earth's story, and of the humility with which we approach it. In that humility lies a gentle invitation to keep looking, to keep wondering, and to accept that some answers may remain beyond our reach, folded softly into the silence of ages. What if the planet itself could be read as a library? Each layer of stone a page, each grain of sediment a letter written slowly by time. This is the thought that guides us as we turn to the geological archives, the quiet record-keepers of Earth. Within these archives lies the only chance to glimpse something from the unimaginable past, not in complete stories, but in fragments and hints. We are not searching for monuments or machines, for those cannot last across hundreds of millions of years. Instead, we look for subtler traces, the kind that the Earth accidentally preserves when conditions align just right. Rocks form in layers, a process simple in description, yet vast in scale. Dust settles, rivers flood, oceans leave behind shells and sand. Over long stretches, these materials press together, harden, and turn into stone. Each layer holds a memory of its own time, storing chemical signals, tiny fossils, or mineral patterns. To read them is to learn the language of archives written not by hands, but by patient processes. Yet we must remember that this language is incomplete. Most of the past vanishes without record. Entire forests, entire species, entire landscapes have come and gone without leaving even a single fossil. The chance of survival is small, the conditions narrow. It is like trying to record history on fragile paper that burns or crumbles almost as soon as it is written. Now, we may pause for a moment with what these archives can and cannot tell us. They are generous in offering snapshots of climate, of volcanic eruptions, of ancient oceans. They show us periods when the air held more carbon, or when glaciers spread across continents. But they are silent about many details. They do not tell us the shape of every creature that lived, or whether a brief civilization rose and fell in a forgotten corner of the world. The record is selective, and in its silences we must be cautious. The language of archives speaks not only through fossils, but also through chemistry. Carbon isotopes, for example, can reveal sudden shifts in climate. Layers of iridium tell of meteor impacts. Even tiny differences in oxygen ratios can whisper of ancient seas. If an advanced civilization had once altered its environment, perhaps traces might show up in these chemical markers. But nature also produces such shifts on its own, through volcanoes, fires, and other forces. Distinguishing one from the other requires care, humility, and often leaves us with unanswered questions. Let us imagine a quiet thought experiment. First, picture a civilization living 300 million years ago. It shapes its world, burns fuel, alters the air. In its time, these changes are obvious, but then it disappears. Over millions of years, sediments cover its traces, mountains shift, oceans spread. What remains is not its buildings, tools, but only a subtle chemical anomaly in stone. Now, step further forward. Another 100 million years pass. Dinosaurs rule, then vanish. More sediments cover the older ones. The signal of that imagined civilization is pressed deeper, blurred, almost erased. Finally, arrive in the present. Scientists drill into the Earth, studying the cores of rock. They find a strange shift in carbon levels, one that does not quite match natural cycles. They debate,
weigh explanations. Consider volcanoes, fires, or unknown causes. A possibility lingers, faint but unprovable. The thought experiment does not give us answers. It shows us instead how fragile evidence can be, and how easily the archives fall silent. This is why absence cannot be read as certainty. To walk through the geological library is to know both its richness and its incompleteness. We can trace broad patterns of life, climate, and catastrophe, but we cannot fill every gap. In those gaps, imagination sometimes wanders, not as proof, but as a way of recognizing how much is beyond reach. And so we soften our conclusions. Geological archives are powerful guides, but not perfect ones. They preserve the memory of deep time, yet they leave vast chapters unwritten. Perhaps nothing more than what we already know lies within them. Or perhaps, buried deeper still, there are faint echoes we have not yet learned to read. For now, we walk slowly among their pages, careful not to rush, listening more to the silences than to the words, and letting the weight of ages remind us how little of the past can truly endure. What if everything we build, no matter how strong it feels in the present, is destined to fade into dust far sooner than we imagine? This gentle thought reminds us of the fragility of traces, the way even the most durable materials are slowly undone by time. A skyscraper of steel and glass looks solid to us, yet in a few thousand years, without care, it would crumble, rust, and sink beneath soil and roots. In the measure of deep time, this happens almost instantly. Now we may pause and think about how this works. Materials have their own lifespans. Metals, when exposed to air and water, turn to oxides and dissolve. Concrete cracks, allowing plants and moisture to break it further. Even stone, which seems eternal, weathers under wind and rain, turning to sand. Glass may last longer, but in geological terms, it too softens, fractures, and disappears. What feels stable in our short view is only temporary when measured against millions of years. Let us take a quiet example. Imagine a modern city left alone, without people. In a few decades, plants creep over the streets. In a century, buildings collapse. In 10,000 years, almost nothing recognizable remains. Extend that further to 1,000,000 years, and the land has shifted, rivers have moved, new soils have covered the last fragments. The city is gone. Now imagine hundreds of millions of years. Entire mountain chains rise and vanish in that span. The traces of our presence would be erased as thoroughly as chalk washed from a slate. And so, if we look backward, to times before the dinosaurs, the absence of obvious remains does not surprise us. It is not proof of nothing. It is the natural consequence of time's slow erasure. We may now linger for a moment with the ways traces can still survive. Not in whole forms, but in indirect markers. A layer of ash may carry particles of metal shaped by fire. Sediments may hold tiny spheres of glass formed in intense heat. Chemical residues, absorbed into soils or oceans, may remain long after the objects themselves are gone. These subtle signals are like shadows, hints of activity rather than clear evidence. Scientists learn to search for such shadows, cautious in interpretation, always aware that nature itself can produce similar effects. Volcanoes, lightning, and impacts from space all leave patterns that resemble those of human industry. Distinguishing intention from accident is delicate, never certain. Let us try a slow thought experiment. First, imagine a civilization long ago, building with metal, shaping stone,
creating objects of beauty and use. Time passes, and the civilization ends. Its works are left to weather and decay. Step further. A few million years pass. Most structures are gone, but faint chemical signatures seep into nearby sediments. A trace of unusual metal, a cluster of altered minerals, rests quietly in the ground. Step again. Tens of millions of years later, the land is lifted into mountains, folded and eroded. The signals scatter, diluted until they are nearly invisible. A geologist in the distant future may find them, perhaps, and pause with uncertainty, unsure if the signal belongs to natural fire or something else. This experiment shows us why fragility matters. It is not that traces cannot endure, but that they rarely endure clearly. They fade, blur, dissolve into the wider language of stone. And so we come to a quiet conclusion. The fragility of traces does not forbid the idea of earlier civilizations, nor does it confirm them. It reminds us instead that time is patient, and that the earth is skilled at wiping its own slate clean. If something came before, its voice would now be hushed, almost impossible to hear. What remains for us is the humility of knowing how little survives, and the calm acceptance that silence does not always mean emptiness. What if the record of life that we hold in our hands is not complete at all, but only a thin and fragile sampling? This thought takes us gently into the world of fossils and absences, the quiet language of what is preserved and what is lost. Fossils feel solid, almost eternal, yet their survival is more an accident than a rule. To become fossilized, a creature must be buried quickly, often in mud or sand, shielded from decay and scavengers. Over time, minerals replace or surround the remains, turning them into stone. Without this precise sequence, no trace is left. Most living beings, plants and animals alike, disappear without leaving a mark. This means the fossil record, as vast as it may seem, is more like a sparse diary than a complete history. We may pause here and notice how selective this process is. Of all the countless species that have ever lived, only a small fraction have left fossils, and of those, only a fraction have been found. Even among fossils we know, the story is patchy, full of gaps, with entire groups absent. If a civilization, or even a simple culture, existed in deep prehistory, the odds of its traces surviving as fossils would be vanishingly small. Now we may linger with the language of absences themselves. Absence is not silence, it too can be read. For example, a sudden gap in the fossil record may suggest a mass extinction. A thin layer of ash across the globe may hint at volcanic eruptions or impacts from space. In this way, the lack of evidence can still tell a story, though it is never precise. When we search for signals of ancient life or activity, we must remember that what we see is not the whole picture, but only fragments left by chance. A gentle thought experiment may help us feel this more clearly. Imagine a forest filled with animals and plants. A storm comes, the forest dies, and most of it decays. A few leaves are caught in mud and preserved as impressions. A single bone sinks into a riverbed and is later mineralized. Millions of years pass, and that bone becomes a fossil. When we discover it, we may think of the forest as populated by one species, but in reality, it was home to thousands. The record has shrunk to almost nothing, and yet we use it to imagine the whole. Step further. Imagine now a human city. When it falls, most of its materials decay. Wood rots, cloth disappears, metals corrode. Perhaps a single shard of pottery survives, or a faint discoloration in the soil where fires once burned. If found millions of years later, that shard might stand as the only evidence of thousands of lives. Step again. Imagine a civilization far older, erased by hundreds of millions of years. Even pottery may not survive that long. What remains might be only a subtle shift in minerals or a trace in chemical ratios within stone. Such signals are real, but almost impossible to read with humanity.
Certainty. This is why absence of fossils, or absence of artifacts, cannot prove that nothing existed. It can only remind us that survival across deep time is rare. We should note, before moving forward, that scientists work with what is available, carefully piecing together stories from fragments. Each fossil is valuable not because it is complete, but because it adds a tiny part to a much larger puzzle. The gaps are always there, and the gaps are vast. Within them lies both humility and wonder. We may then come to a soft conclusion.
Fossils are gifts, not guarantees. Their presence is precious, but their absence does not close the door on possibilities. If civilizations before the dinosaurs ever existed, the odds of finding their bones, tools, or monuments are so small that silence is what we would expect. What we hold instead is the awareness that the record is partial, that nature writes sparingly, and that in the quiet between fossils, entire worlds may have come and gone. What if our sense of time, so tightly bound to short spans of years and centuries, is far too narrow to truly see the scale of the Earth's story? This is where the idea of the cosmic scale of time enters softly, reminding us that we live inside a rhythm far larger than our minds are built to hold. When we speak of billions of years, the words slip easily from the tongue, yet the meaning drifts beyond our grasp. To steady ourselves, let us imagine time as a thread stretched across a vast room. A single human life would be only the smallest point along its length, barely visible, while the history of our civilizations would be nothing more than a faint stitch in one corner. Now we pause to remember the age of the Sun, about 4.6 billion years, and the age of the Earth, slightly less. Stars burn for spans far longer than all of human history combined. Whole planetary systems rise and fall within their lifetimes. Against this background, even the age of dinosaurs, stretching over more than 160 million years, becomes just one chapter in a book whose pages run almost endlessly. If we compare civilizations to such spans, the contrast grows clearer. Human societies, with their cities and technologies, are only a few thousand years old. Industrial activity, which we often see as permanent, has lasted for just a few human lifetimes. 1,000,000 years is vast to us, yet in the cosmic scale it is barely a breath. This helps us see why traces of ancient worlds, if they existed, might vanish so completely. They would be swallowed by time, just as morning dew vanishes under the long sun. Let us now linger with the way cosmic time reshapes the Earth itself. Mountains rise slowly as tectonic plates collide, then crumble under erosion. Oceans open and close as continents drift, merging and breaking apart. Ice ages come and go, grinding landscapes into new shapes. Over tens of millions of years, coastlines redraw themselves many times. In such shifting terrain, no city, no monument, no trace can endure unchanged. Yet cosmic time also leaves quiet markers, and it is here we may look for the language of traces. Layers of sediment accumulate slowly, one upon another, holding whispers of air, pollen, dust, and ash. These build archives that stretch back millions of years. Isotopes of carbon or oxygen change with climate, recording ancient cycles. Minerals form under unique conditions, signaling events like impacts or vast volcanic flows. These markers are subtle yet durable, surviving when other records vanish. If a civilization had once altered its world on a planetary scale, its echoes might appear here, folded into chemical ratios or unusual deposits. Still, the challenge is immense, for natural forces produce signals that can look much the same. Volcanoes release carbon, meteorites scatter rare metals, lightning fuses sand into glass. To separate human-like activity from these natural rhythms is to walk a line of uncertainty, careful not to overstep. Let us explore a gentle thought experiment. Imagine first a civilization that thrives for a few 100,000 years, already longer than ours has lasted. It alters its climate, leaves residues of industry, and then fades. Millions of years pass. The signals of its activity are pressed into stone, scattered in thin layers. Step further. Over tens of millions of years, mountains rise, oceans move, and the traces are buried deeper. Step again. Hundreds of millions of years later, we arrive. Scientists drill into rock cores and find small anomalies, slight enrichments of carbon, traces of unusual metals. They pause, study, compare with volcanic records. They cannot be sure. The signals may point to natural causes, or perhaps to something else, long vanished. The thought experiment does not give us answers. It reminds us instead of perspective. In the cosmic scale of time, permanence is rare, silence is normal. Traces fade not because they never existed, but because time itself is the greatest eraser.
Before moving on, we may gently note that humility is our best guide here. Science proceeds cautiously, aware of the vast unknowns, respectful of silence as much as of evidence. What we learn from the cosmic scale is not certainty about civilizations before dinosaurs, but a deepened sense of how wide the canvas truly is. And so we rest in a quiet pause. Against billions of years, our search is a small light. We may not find what we hope for, yet the act of looking expands our vision. The cosmic scale of time teaches us patience, and it softens our conclusions. We do not say what was or was not. We simply acknowledge how easily the past can vanish, and how vast the stage of Earth remains, waiting with stories we may never fully hear. What if the most enduring memories of the planet are not bones or monuments, but shifts written into its chemistry, quiet signatures that last long after the visible world has vanished? This thought brings us into the language of chemistry, the subtle record-keeping that stone and sediment perform without intention. Unlike cities or tools, which crumble, chemical patterns can endure for tens or even hundreds of millions of years, pressed into the layers of the Earth. They are not photographs of the past, but faint impressions, like the lingering scent of smoke long after a fire has gone out. Let us linger here for a moment and recall what chemistry means in this context. It is the study of elements and how they combine, the building blocks of matter. Within rocks and ice, tiny differences in these building blocks can tell us stories. Carbon, for example, has different forms or isotopes. The ratio between these isotopes shifts when plants grow, when volcanoes erupt, or when vast amounts of fuel are burned. Oxygen too has isotopes, and their balance tells us about ancient oceans and temperatures. These patterns are quiet but persistent. They form a kind of diary that the Earth writes in code. Now we may soften our view to how these codes might carry traces of unusual activity. If an advanced civilization once existed, it may have altered the balance of gases, much as we alter the atmosphere today. Those changes, if large enough, could leave behind layers with unusual chemical fingerprints. Too much carbon in one place, odd distributions of metals, sudden enrichments of elements rarely seen together. Scientists sometimes discover such anomalies, and most are explained naturally. Volcanoes can flood the atmosphere with carbon dioxide, meteor impacts can scatter iridium, fires can blacken sediments across entire continents. Yet the possibility remains that some signals could come from sources we do not yet imagine. We must treat such thoughts with humility, remembering that nature is inventive and complex. The language of chemistry is subtle, and we do not yet know every dialect it speaks. Let us now turn to a soft thought experiment. Imagine, first, a civilization that thrives for thousands of years. It burns fuel, changes the composition of its atmosphere, leaves residues of metals in rivers. When it fades, these signals settle into sediments, thin layers pressed by time. Step further. Over millions of years, new layers cover the old. The chemical signals are locked deeper, yet still present.
Invisible until uncovered. Step once more. Hundreds of millions of years later, scientists drill into the Earth. They find odd shifts in carbon isotopes, unusual deposits of metal oxides, concentrations that do not match expected cycles. They pause, cautious. The signals might mean ancient volcanoes, or fires, or something else. They cannot know for sure. What survives is only the hint, not the story. This experiment shows us how the chemical diary works. It does not tell us who wrote the entry, only that something was written. Before we move on, we may pause with the limits of this record. Chemistry preserves signals, but not intentions. It tells us that the air once changed, that certain minerals appeared, that the oceans shifted in composition. But it does not tell us why. We cannot look at a ratio of carbon isotopes and say with certainty whether it was caused by volcanoes or by industry. We can only weigh possibilities, comparing them, leaning toward the most likely. This is the humility of the scientific approach, a patience with ambiguity. And so we arrive at a quiet conclusion. The language of chemistry is one of the most enduring traces of the Earth, yet it is never complete. It can whisper of great events, of changes in climate, of unusual layers in stone. It may even hold, buried deep, the blurred fingerprints of forgotten worlds. But for now, it speaks only in riddles, and we must listen carefully, without rushing, without forcing answers. In this listening, we learn not only about the past, but about the scale of time itself, and how gently the planet carries its memories forward. What if we borrowed a thought gently proposed by scientists? A simple question they once named the Silurian hypothesis. It asks, if an advanced civilization had lived on Earth millions of years before us, how would we even know? The name itself comes from a geological period, long before dinosaurs, chosen not as evidence, but as a reminder of deep time. This idea does not claim that such civilizations truly existed, but rather invites us to think about what kinds of traces they could leave and how we might search for them. To stay with this thought, we may first recall what science means when it speaks of hypotheses. A hypothesis is not proof. It is a careful suggestion, a way of exploring what might be possible. It allows us to test ideas, to imagine outcomes, and then to look for signals that could support or contradict them. In this sense, the Silurian hypothesis is not about certainty, but about sharpening our sense of what to look for in the vast geological record. Now let us pause with the processes that might preserve or erase such traces. We know that buildings, tools, and ordinary artifacts are fragile. Over millions of years they vanish. But changes to the atmosphere or sediments can endure longer. A civilization burning fuel, producing chemicals, or altering the surface of the planet could leave behind chemical fingerprints in stone. These fingerprints might appear as sudden shifts in carbon isotopes, strange spikes in metals like lead or rare elements, or even in deposits of synthetic compounds that are otherwise unknown in natural cycles. But here we must tread carefully. Nature too leaves such marks. Volcanic eruptions release carbon, spread ash, and deposit metals. Meteor impacts scatter elements rarely found on Earth. Fires, floods, and other natural forces all alter the record in ways that can look artificial. This is why absence of clear evidence does not rule out the possibility, and why ambiguous signals do not count as proof. The challenge lies in distinguishing chance from intention, geology from culture. Let us imagine a thought experiment, following it in quiet steps. First, picture a civilization that changes its environment much as we do now. It burns fuel, alters the atmosphere, and leaves behind waste materials. Over a span of a few 100,000 years, these effects build up. Then the civilization ends. Step further. Millions of years pass. The atmosphere cleans itself, but sediments store the chemical changes. Layers of stone hold odd concentrations of carbon, unusual metals, perhaps even molecules not otherwise known. Step once more. Hundreds of millions of years later, scientists uncover these layers. They see the anomalies, measure the ratios, compare with known volcanic or meteoritic events. The signals do not match perfectly, but they are faint, blurred, and hard to explain. The scientists must then decide whether to call them geological accidents or possible traces of something else. This experiment shows us the quiet value of the Silurian hypothesis. It is not that it proves ancient civilizations, it is that it gives us a framework for thinking, a way to notice what could be significant in the geological archives. It widens the search without insisting on answers. Before moving on, let us note the humility in this approach. Science here admits its limits, acknowledging that deep time erases most records and that what remains may be too faint to interpret. Yet it also shows curiosity, the willingness to ask, even when the answer is uncertain. And so we may rest in a gentle conclusion. The Silurian hypothesis reminds us that if civilizations existed before dinosaurs, their clearest traces would not be statues or machines, but chemical shadows in stone. None have been found with certainty, yet the act of asking teaches us to look differently at the Earth's memory. It is not proof, nor denial, but an invitation to patience and openness, letting us listen more carefully to the whispers written in the layers beneath our feet. What if the world itself is not only a stage for life, but also a slow erasure, quietly removing almost everything that has ever been placed upon it? This brings us to the long work of erosion and the quiet, patient forces that reshape the surface of the planet. They do not rush, they do not tire. They move steadily, grain by grain, drop by drop, until even the most enduring structures soften and vanish. In our brief human view, a mountain looks eternal, a monument seems permanent, a city feels solid. But when measured against millions of years, all of these dissolve into landscapes unrecognizable from their beginnings. Now let us pause with the main players in this erasure. Water, flowing in rivers and rain, carves valleys and carries away stone as fine sediment. Glaciers, slow rivers of ice, grind mountains into powder. Wind lifts grains of sand, moving them across deserts and plains. Volcanoes bury and remake land, while earthquakes break apart what once stood firm. These are ordinary forces, not dramatic when viewed from the scale of a single day, but relentless across the scale of deep time. The process is simple. Surfaces are broken down, transported, and redeposited elsewhere, layer upon layer. In this cycle, permanence is an illusion. Let us now consider what this means for traces of civilizations, should any have existed before the dinosaurs. Buildings, roads, or machines would not survive long under such treatment. Metals corrode, stone is ground away, glass turns to grains of sand. Even vast monuments would erode until only faint scars remained, and those too would be erased as the land itself shifted. Entire continents drift and collide. Ocean floors are recycled back into the mantle of the earth, melted and remade. Against these movements, even the strongest artifacts are fragile. Now we may pause with the limits of what we can know. Because the earth is so active, because its surface is constantly renewed, our geological archives are incomplete. They preserve snapshots, but not the whole story. Much of the record has been erased. This is why the absence of visible ruins from distant ages cannot be taken as proof that none ever existed. It is simply the nature of time and geology to sweep the slate clean. Yet sometimes erosion itself leaves indirect signals. Layers of unusual sediment may show where mountains once stood. Pebbles smoothed by glaciers tell of vanished ice. Ash beds mark ancient eruptions. These are the traces of erasure, the faint outlines of what once was, even though the original forms have disappeared. If civilizations had ever risen in such distant epochs, perhaps their passing too would leave only indirect shadows, chemical residues, odd mineral distributions, subtle patterns in layers of stone. Let us try a quiet thought experiment. Imagine first a great city built long before the age of dinosaurs. Its towers and roads stretch across a wide plain. Then step forward in time. Millions of years pass. Rivers shift, mountains rise nearby, glaciers advance and retreat. The city crumbles, its remains buried, then ground away. Step further. Tens of millions more years pass. The plain itself lifts into a mountain chain, only to be eroded once more. The city is gone. Step again. Hundreds of millions of years later, only a faint chemical anomaly remains in the sediments downstream. A scientist uncovers it, puzzled but unsure. The city itself is lost, its memory erased by the patient hand of erosion. From this we see how erasure works, not suddenly, but slowly, steadily, until absence itself becomes the norm. Before moving on, let us rest with this awareness. The planet does not preserve everything. It chooses through chance and circumstance. What survives is precious, but most is lost. The quiet lesson is humility. We cannot expect the Earth to hold clear answers to questions of civilizations that may or may not have existed so far back in time. What we can do is read carefully the fragments that remain, knowing how easily they might have vanished. And so we end this thought with a gentle balance. Erosion is both destroyer and teacher. It takes away, but it also leaves signs of its taking. In the silence it creates, there is space for imagination, not as proof, but as reflection.
The patience of water, wind, and stone reminds us that deep time is not generous with memories, and that what we search for may be long gone, softened into the landscape itself, waiting quietly as part of the Earth's endless cycle. What if the deepest places on our planet, the vast ocean floors, once carried traces of lives and works now entirely erased? This thought invites us to pause with the oceans, which cover most of the Earth's surface and yet hide their history more completely than land. To understand this, we need to linger for a moment on how the seabed renews itself. Unlike the continents, which can preserve ancient rocks for billions of years, the oceanic crust is young and restless. It forms along mid-ocean ridges where molten stone rises from beneath the planet's skin, cools, and spreads outward. Slowly, over tens or hundreds of millions of years, this crust moves until it sinks back into the Earth's mantle through deep trenches. This process is called subduction, and it means that the floor of the ocean is constantly recycled. No part of it survives for more than about 200 million years. In the measure of deep time, this is only a brief moment. Now we may soften our view and think about what this means for traces of civilizations. If any advanced culture had once lived upon or beneath the oceans long before the age of dinosaurs, its works would not remain for us to discover. Cities, machines, monuments, if they ever existed there, would have been pulled slowly downward, melted, and returned to the deep interior of the Earth. What once was surface becomes magma. What once stood above waves becomes part of the unseen cycle beneath them. For us, the result is silence, not because nothing was there, but because the planet itself is a patient eraser. We might now pause with the indirect ways oceans still keep a kind of memory. Sediments, which are layers of particles settling through the water, collect on the seabed. These sediments may hold tiny fossils, grains of pollen, volcanic ash, even traces of atmospheric changes. In their upper layers, stretching back tens of millions of years, we find valuable records of climate and life. But because the crust beneath is young, older layers are lost to subduction. The ocean keeps short diaries, never long epics. And so the window we can look through is narrow. If we extend this thought through a
gentle experiment, the erasure becomes clearer. Imagine, first, a civilization building on the seafloor 300 million years ago. Its structures rise above the currents, its lights glow in the depths. Step forward. Over tens of millions of years, the crust beneath begins to move. Sediments cover the ruins, then the whole region drifts toward a trench. Step again. The crust sinks, carrying the last traces downward. Heat and pressure melt them away. Step once more. Hundreds of millions of years later, new crust forms in a different place, young and bare. Nothing remains of the old. What we hold now is only imagination, and the awareness that the Earth has cycles that erase more than they preserve. Before moving on, we may note the humility this teaches us. When we look for ancient civilizations, we often search on land, where ancient rocks still survive. But in the oceans, which are most of our world, the record is constantly wiped clean. This does not mean nothing could have been there. It means simply that the archive is missing, pages torn out as soon as they are written. And so we rest in a quiet conclusion. The oceans are both generous and silent. They hold recent history in their sediments, offering clues to climate, life, and change. But they do not hold the very old. If there were civilizations before the dinosaurs that lived upon or beneath the seas, their traces are now gone, melted into the deep circulation of the Earth. We cannot retrieve them, only reflect on how much is beyond reach, and how the patience of the planet reminds us that what seems permanent may vanish almost completely in the slow turning of geological time. What if the land beneath our feet, which feels so steady, is in truth a traveler, always on the move, reshaping itself across the long rhythm of deep time? Continents are not fixed, though they appear so in our short view. They drift slowly, carried by currents of molten rock deep within the Earth. This quiet movement is called plate tectonics.
Imagine a raft gliding almost imperceptibly on a vast ocean. The speed is slow, measured in centimeters per year. But given millions of years, continents cross entire oceans, collide, and separate again. Step again. Now we may pause with what this means for traces of civilizations, should any have existed before the dinosaurs. A city built on one shore might, millions of years later, be lifted into a mountain range, or broken apart and scattered as islands. A plain covered in roads could be submerged beneath a shallow sea, then buried in sediments, and later raised again into dry land. With every shift, the traces of what once stood there are disturbed, buried, or erased. The map of the world is never the same for long in geological terms. What feels permanent to us is temporary in the language of the planet. Let us linger on the archives this process leaves. When continents collide, they push up mountains, and in the layers of those mountains we sometimes find pieces of ancient seafloor, fossils of creatures that once lived in oceans now long vanished. These are indirect markers of movement, reminders that landscapes have traded places many times. If an advanced culture once left signals on the surface, those signals may now lie hidden within mountain chains, folded, crushed, and transformed by heat and pressure. They may survive only as chemical shadows, not recognizable as anything built by hands. Now we may try a gentle thought experiment. Imagine first a civilization living on a vast lowland 300 million years ago. Its structures spread widely, its marks carved into stone. Step forward in time. The land drifts slowly, colliding with another continent. Mountains rise, folding the lowland into peaks. The structures are broken, their stones pressed into new forms. Step further. Tens of millions of years later, erosion wears the mountains down. Rivers carry fragments to the sea. The old land is reduced to grains of sand, scattered far from where it began. Step once more. A geologist in the far future studies the mountain rocks and notices unusual minerals, but cannot
tell their origin. The story of the civilization is gone, swallowed by the drifting of continents. From this thought, we see how the moving land reshapes not only geography, but memory itself. What survives is partial, fragmented, and hard to interpret. This is why the absence of clear evidence is not certainty of absence. The shifting earth has a way of erasing, folding, and rewriting its surface, leaving only faint hints of what once stood. Before moving further, we may pause with the humility this invites. Our search for traces of deep prehistory is always conducted in landscapes that have been moved, reworked, and reshaped many times. We are never looking at an untouched canvas. We are reading a palimpsest, a page written over and again. And so we come to a quiet conclusion. The drifting of continents makes the search for ancient civilizations even more uncertain. Land is not fixed, archives are not stable, and what might once have been visible is now lost in mountains, seabeds, or scattered grains of sand. This does not close the possibility that something once existed. It reminds us instead that the Earth's surface is patient and restless, keeping its secrets not by hiding them, but by changing so completely that the past becomes unrecognizable. In this recognition, we find not answers, but perspective, and a calm awareness of how fragile traces truly are against the steady movement of the ground beneath us. What if the most enduring relics of forgotten worlds are not grand monuments or vast cities, but the smallest fragments, those rare survivors that slip through time's patient erasure? This gentle thought leads us to the idea of what endures when almost everything else is gone. In the scale of hundreds of millions of years, only a few kinds of matter remain recognizable. Shells turn to stone, minerals hardened into crystals, traces of carbon locked into rocks. These are the rare survivors, not of intention, but of chance. Now we may pause with the processes that allow such survival. Fossilization, though often spoken of as common, is in truth unusual. Most remains of plants and animals disappear, yet under certain conditions, buried in mud, sealed away from oxygen, exposed to minerals, they are preserved.
A leaf may leave its delicate impression in shale. A shell may turn to stone. A bone may be filled with minerals and endure. Beyond fossils, crystals and minerals have even longer lives. Quartz, for example, can last nearly unchanged through countless cycles of erosion and burial. Diamonds, formed deep in the earth, can outlast entire mountain chains. These rare materials are like small windows through which the distant past still peers. We may now linger on what this means for traces of civilizations. If there had been builders before the age of dinosaurs, their stonework would likely be gone, their metals corroded, their tools reduced to dust. Yet perhaps a few objects, if carved in mineral or made in unusual forms, might resist longer. A worked crystal, a melted fragment of glass fused into stone, or a peculiar alloy encased in sediments could endure far beyond ordinary matter. The difficulty lies in recognition. Nature itself creates intricate shapes, crystals of astonishing geometry, glass formed by lightning striking sand, metals deposited by hydrothermal vents. Distinguishing an artifact from a natural creation becomes delicate, a puzzle where the line between accident and intention blurs. Now let us try a gentle thought experiment. Imagine first a civilization shaping objects from quartz, carving intricate forms. Time passes and the civilization ends. Erosion breaks most apart, but one or two pieces sink into mud and are buried. Step further. Millions of years pass. Sediments harden, mountains rise, rivers cut valleys. The carved quartz remains, though weathered and scarred. Step once more. Hundreds of millions of years later, a geologist uncovers the object. At first glance, it looks like a natural crystal. Only under close study does its shape suggest deliberate work. Even then, the doubt remains. Is it a
natural oddity or the last whisper of a lost world? This shows us how fragile certainty becomes when dealing with rare survivors. The Earth keeps only fragments, and fragments often resist clear interpretation. Now we may note the limits of our knowledge. Archaeology works well across thousands of years, sometimes millions, when fossils and artifacts remain. But in the scale of hundreds of millions, almost everything is erased. What endures is so little, so altered, that we cannot always tell its story. The silence is not proof of nothing, but a reminder of how little survives. And so we arrive at a quiet conclusion. Rare survivors exist, but they are few and ambiguous. They may be natural, they may be cultural, and often we cannot tell. Their value is not in proving or disproving forgotten civilizations, but in showing us that some things do endure, that the Earth does not erase everything. In their presence, we glimpse how fragile and yet how resilient matter can be, and how uncertain our reading of the deepest past must remain. It is in this uncertainty that humility grows, and in this humility we find a calm acceptance that the Earth's memory is partial, carrying forward only a few rare fragments while letting the rest dissolve into silence. What if the long silence of deep time is itself a kind of message? Not a denial of past possibilities, but a reminder of how much the Earth chooses not to keep. We may think of the planet as a storyteller who whispers a few fragments and then falls quiet again, leaving us with gaps larger than the words we receive. In those pauses, we are tempted to draw conclusions, but we must remember that silence is not certainty. It is only absence, and absence is shaped as much by chance as by truth. Now we may pause to consider how this silence comes to be. Layers of stone preserve only what conditions allow. Bones must be buried quickly to fossilize. Sediments must accumulate in just the right way to trap pollen, ash, or dust. Even then, heat and pressure may later erase the traces. Most of what has ever lived, and most of what has ever been built, is simply gone. The deeper into time we look, the stronger this silence becomes. For stretches of hundreds of millions of years, only thin signals remain. Chemical ratios, tiny fossils, faint mineral patterns. These are not stories, only fragments. And yet, even in this quiet, we can listen for meaning. Now we may linger with the language of science, which treats silence not as proof of nothing, but as a space of uncertainty. When geologists see a gap in the record, they do not assume nothing happened. They mark it as an unconformity, a missing chapter. In this way, the absence itself becomes data, a clue that time passed without preservation. If we apply this to the idea of ancient civilizations, the same logic holds. The lack of evidence is expected, given the fragility of traces. It does not rule out the possibility. It only reflects the limitations of what the Earth chooses to archive. Let us try a gentle thought experiment. Imagine, first, a world where a civilization rises long before the dinosaurs. It thrives for a short geological moment, then disappears. Step further. Over millions of years, erosion sweeps its monuments away, continents drift, oceans recycle their floors. Almost nothing remains. Step once more. In the present, scientists search the rocks and find no clear trace. The silence is complete. But does this silence prove that nothing existed? Or does it simply remind us that even if something had been there, the Earth would almost certainly have erased it? The thought experiment shows us that silence alone cannot settle the question. Now we may rest for a moment with how this silence feels. For some, it is frustrating, a barrier to knowledge. For others, it is calming, a reminder that not all questions must be answered. In the rhythm of a documentary for sleep, this silence is like the pause between breaths, a space that carries weight precisely because it does not speak. And so we come to a soft conclusion. The silence of deep time does not resolve the question of civilizations before dinosaurs. It leaves us instead with humility. We cannot know everything. We can only read the fragments we are given, careful not to mistake their incompleteness for certainty. The quiet is not proof, nor is it denial. It is simply the sound of time itself, moving patiently, erasing much, preserving little, and leaving us to wonder gently in the spaces between what is known and what is lost. What if intelligence itself is not a single chance event, but something that could arise more than once, scattered across the long expanse of planetary history? This is not to say it has, only to acknowledge that the stage is wide enough for more than one performance. When we look at probability, we see a quiet reminder that life is abundant in variation, and intelligence is one branch of that tree. We cannot be sure if it is rare or inevitable, but in the measure of deep time, there is room to wonder. Now, we may pause with what probability means in this context. It is not a prediction of what must occur, but a way of describing chances. Like rolling a die, the outcome of a single throw is uncertain, but with enough throws, patterns emerge. The Earth has hosted billions of years of life, with countless species rising and falling. Within that immensity, intelligence appearing more than once is not beyond possibility. Still, possibility is not proof, and we must hold this thought gently. Let us now soften our view by looking at known patterns. Complex traits, such as vision, wings, or social behavior, have evolved more than once in different groups. This is called convergence, the tendency for life to find similar solutions under similar pressures. If complex traits can arise multiple times, then perhaps intelligence too could emerge again, shaped by different paths. But intelligence is not simple. It is not just having a brain or tool use. It is a layered combination of language, cooperation, memory, and technology. Whether such a mix could emerge repeatedly is uncertain. This uncertainty is the ground we walk upon. Before we move further, let us note how probability leaves silences. We cannot calculate with certainty how likely it is for civilizations to appear. Our sample size is one, ourselves. With one example, it is impossible to draw strong conclusions. We can say only that it has happened once, and that once shows it is possible. Whether it is common or vanishingly rare remains hidden. Still, even in the absence of answers, the question widens our vision. Now, let us imagine a quiet thought experiment. First, picture the early Earth, rich with oceans and simple life. Over millions of years, some creatures evolve intelligence, building tools and shaping their environment. Step further. That civilization thrives for a time, but like all species, it eventually fades. Its traces erode, drift, and vanish. Step again. Millions of years later, life continues to diversify. New forms emerge, unrelated to the first. From these, a second intelligence arises, different in form but sharing the spark of curiosity. The planet has rolled the die again. Step once more. In the present, we look back, but we see only fragments, fossils, and chemical shadows. The first civilization is gone, the second is unknown. All that remains is ourselves and the silence that stretches before us. This thought experiment does not give us answers, but it shows how probability works across time. Given enough chances, unlikely things may still happen. Now, we may rest for a moment with the traces we might expect if such cycles had occurred. Geological layers preserve shifts in carbon, metals, or isotopes. These could serve as indirect markers, faint and ambiguous. Yet most signals blur together, and distinguishing the footprint of life from the hand of civilization is difficult. Silence may be expected, even if something once existed. And so we come to a gentle conclusion. Patterns of probability allow us to imagine civilizations arising more than once, long before the dinosaurs or long after us. But evidence remains elusive, and silence may be the only record we will ever have.
Here. This does not close the door. It leaves it ajar, inviting patience, humility, and quiet wonder at the vast possibilities that deep time may have held, even if most of them slipped away without leaving clear traces. What if the rise and fall of civilizations, whether human or imagined long before us, follows the same rhythm as the lives of species? A cycle of flourishing, decline, and disappearance. This thought leads us into the quiet lessons of extinction, the reminder that nothing on Earth, no matter how powerful it seems in the moment, is truly permanent. Species come and go. Ecosystems bloom and fade. The same may be true for civilizations, whether ours or those that might have existed in ages lost. Now let us pause to see how extinction works. Most often, it is not sudden, but gradual, like a candle burning low. A species may decline as its environment shifts, as food becomes scarce, or as competition grows. Sometimes, though, extinctions happen quickly, driven by great events. An asteroid impact, a massive volcanic eruption, a sudden change in climate. These events ripple across ecosystems, and within a geological blink, countless forms of life vanish. Extinction is not rare, it is the rule. More than 99% of all species that ever lived are now gone. Let us linger here for a moment. If life itself is so temporary, can civilizations expect to be different? A city or a culture is fragile in its own way, bound to resources, climate, and stability. A drought may weaken it, a disaster may end it. Even without catastrophe, time alone ensures change. What once thrived eventually gives way to something new. The Earth remembers in cycles, not in permanence. We may now turn to the language of traces. Extinctions leave signals in the geological record. A sudden drop in biodiversity shows in the fossil layers. Ash or unusual isotopes mark volcanic winters or impacts from space. Even chemical shifts in sediments speak of oxygen falling or carbon rising. In this way, the absence of life becomes a kind of presence in stone. If civilizations existed before the dinosaurs, perhaps their endings too would have left such indirect markers. Not monuments, but strange changes in layers, signals of fire, pollution, or sudden absence. Let us try a gentle thought experiment. Imagine first a civilization flourishing in deep time, shaping its world with tools and industry. Step further. The climate shifts or a great disaster arrives. The civilization collapses, and within a few thousand years, its traces fade. Step again. Millions of years later, the land where it once lived holds only subtle markers. An unusual chemical pattern, a thin dark line in sediments, a sudden drop in certain fossils. Step once more.
Scientists in the far future study the rocks and see the signals, but they cannot tell whether these marks mean a natural event or the quiet end of a culture now erased. This experiment shows us the fragility of civilizations against the scale of the Earth. Their rise may be grand, but their fall is quick in geological terms, and their memory is faint. Before moving forward, let us rest with the humility this brings. The absence of clear evidence does not mean civilizations never existed. It only reminds us that extinction, whether of species or cultures, is the expected path of time. What survives is not the builders, but the traces, and even those are few. And so we reach a soft conclusion. The rhythm of extinction is part of the planet's story, steady and unbroken. It takes life, and it may have taken civilizations we will never know. What it leaves is silence, punctuated by faint markers in stone. We cannot say with certainty what was lost. We can only acknowledge the pattern and find perspective in knowing that everything, even ourselves, moves within this larger cycle of emergence and disappearance.
Mark for us to find. This gentle thought leads us to reflect on the limits of our imagination when we look for traces of deep prehistory. We tend to expect the familiar, cities, machines, monuments. But intelligence could have chosen different paths, creating in ways that dissolve completely in time. Now, we may pause and think about what technology means at its simplest. It is any means by which living beings extend their abilities, using tools to shape the world, energy to move or to build, knowledge to organize. We imagine gears, engines, wires, but technology could have been woven from organic matter, or based on energy that leaves no residue, or structured in ways that do not fossilize. Our search, shaped by our own perspective, might miss what does not resemble us. Let us now linger on the limits this creates. Archaeology is skilled at finding stone, bone, ceramic, and metal. These endure long enough to be discovered. But in the scale of hundreds of millions of years, even stone crumbles. If a civilization before the dinosaurs had built from wood, fiber, or other fragile substances, nothing would remain. If its energy left no smoke, no ash, no chemical disturbance, the record would be blank. We must acknowledge that our tools for detection are designed for familiar signals, not for unknown possibilities. Now, we may rest a moment with the language of traces. Modern civilization, even in its brief span, has left chemical fingerprints, carbon in the atmosphere, plastics in sediments, radioactive isotopes in soils. These are durable signals, yet still limited in time. If another civilization had relied on subtler technologies, perhaps based on biological processes or clean forms of energy, its traces might be invisible to us. Absence of signals does not mean absence of existence. It may mean simply that our eyes are not tuned to the right spectrum. Let us try a quiet thought experiment. Imagine first a civilization that grows not by building monuments, but by cultivating living systems. Forests shaped into structures, organisms engineered for tasks. Step further. When the civilization ends, the forests return to wildness, the organisms blend back into ecosystems, the traces fade within thousands of years. Step again. Millions of years pass, continents drift, climates change. No physical artifact survives. Only subtle shifts in the fossil record hint that something unusual once shaped the world. Species that appear suddenly, distributions that defy natural expectation. Step once more. Scientists in the far future see these patterns but interpret them as natural evolution. The civilization is gone, its story hidden. This experiment shows us how fragile our categories can be. What looks natural may sometimes carry echoes of design. But because design and nature often converge on similar outcomes, we cannot separate them with certainty. The humility here is deep. Before we move on, let us note the caution this brings. We cannot claim evidence where there is none, and we must not mistake imagination for fact. Yet, it is valuable to widen our perspective, to remember that our kind of technology is only one among countless possibilities. Intelligence, if it ever appeared before us, may have spoken in a language of tools that time has erased completely. And so we come to a soft conclusion. Imagined technologies remind us that our search is always partial, shaped by our assumptions. The Earth's silence does not mean nothing was ever here. It means only that, if something was, it may have built differently, in ways that leave no fossil, no shard, no ruin. This awareness does not give us answers, but it expands the horizon of thought, reminding us of the vast diversity that deep time could hold, even if most of it has slipped beyond our reach, leaving only the quiet possibility behind. What if the traces of ancient civilizations, if they ever existed before the age of dinosaurs, are not written in stone or metal, but in more subtle layers, clues that resemble the footprints of climate itself? We may pause here to reflect on how our own time leaves signals that could last.
Far beyond us. The fuels we burn, the chemicals we release, the reshaping of land and sea, all of these leave quiet imprints in sediments and in the air. If another species far in the future were to study the rocks of our age, it would find unusual signatures. Sharp rises in carbon dioxide, deposits of plastics, radioactive isotopes, even shifts in biodiversity. These are not monuments, but they are still marks of our presence. Now let us soften our focus to the processes that make such signals endure. Carbon, when burned in vast amounts, alters the ratio of isotopes in the atmosphere. These isotopes are then absorbed into oceans, plants, and eventually into sediments. Millions of years from now, a thin layer in rock might preserve that shift. Similarly, plastics, though fragile in our eyes, can fragment into tiny particles and become part of the geological record. Even radiation, invisible and intangible, leaves traces in soils that can persist long after reactors or bombs are gone. This quiet language is called the stratigraphic signal, the record of change captured in layers of the Earth. Let us now linger on the humility this brings. If we can imagine our own civilization leaving behind chemical whispers rather than solid monuments, we can also imagine that any civilization long before us might have done the same. Perhaps they altered their climate, or changed the chemistry of oceans, or triggered extinctions of species. These effects could linger faintly in the record. Yet we face a problem. Natural forces leave similar marks. Volcanoes release carbon, meteors scatter rare metals, ice ages shift oxygen levels in the seas. Distinguishing cultural fingerprints from geological rhythms is not simple. Now we may try a thought experiment. Imagine first a civilization in deep prehistory, burning fuel from vast forests, releasing carbon into the air. Step further, the civilization ends, but the carbon remains, absorbed into sediments. Millions of years pass. The forests turn into coal beds, new species rise, continents drift. Step again. Hundreds of millions of years later, scientists uncover the layer. They find a sharp anomaly in the carbon ratios, different from the surrounding rock. They pause, wondering, was this the mark of volcanoes or of something more? The evidence cannot decide. It is only a hint, blurred by time. This experiment shows us the difficulty of reading such subtle signs. The signal survives, but its meaning is uncertain. Before moving on, let us note a simple truth. Evidence does not speak in full sentences. It whispers in fragments. Science listens, compares, and tests, but it rarely concludes with absolute certainty when dealing with the deep past. What remains is probability, suggestion, and the acceptance of ambiguity. And so we come to a gentle conclusion. Anthropogenic signals, the marks of civilization, may outlast us, not as monuments, but as shifts in chemistry, layers in stone, changes in life itself. If such signals exist from before the dinosaurs, they would be faint, ambiguous, easily mistaken for natural cycles. We cannot say they are there, but we cannot say they are not. In this balance, we are reminded to look humbly at our own place in time, and to listen carefully to the quiet layers that hold the Earth's memory,
fragile and incomplete, yet endlessly deep? What if the Earth itself carries a quiet rhythm, a cycle of ages in which life and even civilizations could rise more than once, leaving only faint shadows behind? This thought leads us into the idea of recurrence, the possibility that the planet's history may not be a straight line, but a sequence of patterns repeating on scales too vast for our immediate sense of time. Now we may pause with what cycles mean in nature. Seasons return each year, tides move in and out, ice ages come and go. On larger scales, continents drift apart and reunite, climates warm and cool, oceans open and close. These rhythms suggest that the Earth is not a static place, but a moving, pulsing system. If we extend this thought, it becomes possible that intelligence itself might not be unique to us, but part of a pattern that could emerge, fade, and perhaps reappear. Let us linger for a moment with the processes that shape recurrence. Evolution is not predetermined, yet it often finds similar solutions when conditions resemble each other. Eyes have evolved more than once, as have wings, as have complex societies among animals. This convergence shows us that certain forms are likely to arise again, even from different beginnings. Intelligence may follow a similar path, appearing in different epochs when circumstances allow. But here we must note the limits of what we can know. Our evidence for civilizations is bound to the present and to recent geological records. The deeper we go into time, the more silence surrounds us. Rocks are recycled, oceans erase, mountains crumble. What survives is fragmentary, and so we cannot say with certainty whether cycles of civilizations have ever unfolded. What we can say is that the stage is wide enough and the play of time long enough for the possibility. Now we may turn to the language of traces. If civilizations did recur, we might expect to see repeating signals in the record. Layers with sudden changes in carbon, clusters of extinctions, odd chemical anomalies that appear in intervals. Yet distinguishing these from natural cycles, volcanoes, impacts, shifts in climate, is delicate. The Earth's own rhythms mimic what civilizations might leave, and so the signals blur together. Silence, again, is not proof of nothing, but a reflection of how faint the traces are. Let us try a quiet thought experiment. Imagine first a civilization flourishing 300 million years ago. It alters its environment, leaves behind subtle chemical fingerprints. It vanishes, its traces fade. Step further, tens of millions of years later, life diversifies again. New forms evolve. Another civilization arises, perhaps different in shape, but similar in its impact. It too leaves faint signals, then disappears. Step once more. Hundreds of millions of years later, we look back. The geological record shows anomalies here and there, carbon shifts, extinction spikes, unusual layers of ash. They could be natural, they could be cultural. We cannot decide. The pattern may be there, or it may be an illusion of chance. This experiment shows us how recurrence, if it happened, would be nearly invisible. Before moving on, let us note the humility this requires. We are skilled at reading the Earth, but the text we study is incomplete, written in fragments, and erased many times. To see patterns where the record is faint may be imagination, but to ignore the possibility may be too narrow. The balance is delicate. And so we arrive at a gentle conclusion. The idea of recurrence does not tell us what was, but it widens our sense of what could have been. It reminds us that time is long, that the Earth's rhythms are vast, and that intelligence, like wings or eyes, might not be a singular miracle, but a potential note in the larger music of life. Whether it has sounded before, we do not know. We can only listen to the silence and wonder softly if the melody of civilization has echoed more than once across the deep ages. What if the memory of ancient civilizations, if any truly existed before the time of dinosaurs, is not found on the land or in the oceans, but hidden within the quiet cores of ice and sediment that the planet has preserved as its diaries? These natural archives do not give us monuments or artifacts, but they do capture the breath of the Earth, its air, its dust, its chemistry, sealed away across long stretches of time. We may pause here and think about how these cores work. In polar regions, snow falls year after year. Over centuries, the weight compresses it into ice, trapping tiny bubbles of ancient atmosphere. When scientists drill into these layers, they read concentrations of carbon dioxide, methane, and other gases. Each slice of ice a snapshot of the air as it once was. In lakes and oceans, sediments accumulate in layers, carrying pollen, ash, and particles. These layers harden slowly, becoming thin, delicate records of climate.
Vegetation, and sometimes even distant fires. Together, they are like journals written not by hands, but by seasons. Yet now we must soften our view with a reminder of scale. Ice cores give us windows into hundreds of thousands of years, sometimes a little more, but not hundreds of millions. Sediments can reach further, but they too are disturbed, shifted, and lost with time. The deeper into history we look, the fewer records remain intact. Still, for the spans they cover, these cores provide some of the clearest pictures we have. And if civilizations once altered their air, their soil, or their vegetation, the echoes could, in theory, have been sealed away in such records. Let us linger briefly on the kind of signals one might expect. A sudden rise in greenhouse gases could point to large-scale burning of fuel. Ash layers with unusual chemical content might suggest fire beyond volcanic activity. Shifts in pollen could show abrupt changes in vegetation, as if forests had been cleared on a wide scale. These are indirect signs, never certain, but they remind us that human activity today already leaves comparable marks. Now we may try a gentle thought experiment. Imagine first an ancient civilization that alters its climate, releasing carbon into the air. Step further. Snow falls on distant poles, sealing bubbles of that changed atmosphere into ice. In lakes and seas, sediments capture the dust, the ash, the altered pollen from shifting landscapes. Step again. The civilization vanishes, erased by time. But in the cores of ice and sediment, the faint chemical trace remains, compressed and layered, waiting quietly. Step once more. Millions of years later, scientists recover a fragment of these cores. They see anomalies, puzzling and unexplained. They compare with volcanoes, with wildfires, with natural cycles. The signals do not fully align, yet the cause remains uncertain. The civilization is gone, but the breath of its world lingers in trapped bubbles of ancient air. Now we must rest a moment with the limits. Ice melts, sediments shift, layers fold into mountains or sink into the sea. What survives is fragmentary, partial, blurred by countless cycles. Even if unusual signals were once recorded, their meaning may now be undecipherable. The Earth's journals are rich but fragile, and many chapters are missing. And so we come to a soft conclusion. Ice and sediment cores remind us that the planet does keep records, but only for spans that are short compared to the full depth of time. They show us how civilizations, even ours, leave fingerprints not in stone, but in the chemistry of air and soil. If others once existed before the dinosaurs, their signals would be faint and perhaps already erased. Yet the very act of looking into these cores teaches us humility. To see that the Earth remembers some things, forgets most, and whispers only fragments to those patient enough to listen. What if the marks of ancient civilizations, if they ever existed in times before the dinosaurs, could be found not in visible ruins, but in the invisible record of isotopes, the subtle variations of atoms that act as timekeepers of the Earth? This thought leads us gently into the world of geochemistry, where the smallest differences hold the memory of great events. An isotope is a form of an element, almost the same as its twin, but slightly heavier or lighter. Carbon, for example, comes in light and heavy forms. When plants grow, they prefer the lighter kind, leaving behind a different balance in the air and soil. Oxygen, too, shifts in subtle ways depending on climate and ice. These balances are sealed in sediments and rocks, becoming quiet markers that last for millions of years. Now we may pause to reflect on how isotopes are used to read the past. By studying the ratios of carbon, oxygen, or nitrogen in layers of stone, scientists can tell when climates warmed or cooled, when oceans lost oxygen, when vast forests grew or disappeared.
These patterns are like a diary written in code, telling of great cycles in the planet's story. If civilizations had once burned fuel, cleared land, or altered the atmosphere, their actions
might have shifted these isotope balances too. The Earth would not record their names, but it might still hold the chemical echoes of their presence. Let us linger for a moment on what this would mean. A sudden rise in light carbon isotopes, for instance, could reflect large amounts of organic matter burned. We see such a signal at the end of the Permian period, when more than 90% of life vanished. The usual explanation is vast volcanic eruptions releasing carbon. Yet in theory, such a signal could also be left by industrial-scale burning. Here, humility is needed, for natural causes and cultural causes may leave traces that look almost the same. Now we may try a gentle thought experiment. Imagine first a civilization flourishing hundreds of millions of years ago. It uses energy on a grand scale, burning fuels, changing its air. Step further. These changes shift the carbon balance of the atmosphere. Sediments absorb the altered ratios. The civilization ends, but the chemical marks remain. Step again. Millions of years pass. The planet reshapes itself. Mountains rise and fall. Oceans advance and retreat. The signals are buried deeper. Step once more. In the far future, scientists measure a sudden anomaly in carbon isotopes. They compare it with volcanic records. They see that it could fit, but it could also mean something else. The civilization is gone, but the isotopes whisper of a disturbance beyond the ordinary. This experiment shows us how isotopes can be both precise and uncertain. They capture change faithfully, but they do not reveal its cause. We are left with hints, with puzzles, with signals that can be read in more than one way. Before we move further, let us rest with the reminder that science builds on caution. The same anomaly can have many explanations, and to choose among them requires care. The absence of certainty is not a weakness, but a recognition of the complexity of nature's language. And so we arrive at a quiet conclusion. Isotopes are among the most durable records the Earth keeps, and they may carry the faintest shadows of events we cannot otherwise see. If civilizations before the dinosaurs ever existed, their greatest legacy may be written not in stone or metal, but in the delicate balance of atoms within ancient rocks. We cannot be sure. We can only listen to the isotopic signals with patience, acknowledging that they may mean many things, and that in their ambiguity lies both the beauty and the humility of studying deep time. What if the faintest clues of ancient civilizations are not in artifacts or isotopes, but in the quiet shapes of landscapes themselves, in the patterns that seem natural yet carry hints of design? We often think of geology as purely the work of rivers, winds, and tectonic shifts. Yet landscapes can also be shaped by intention, by the hands of life itself. Over time, that intention fades, blurred by erosion and growth, until only the pattern remains. Now we may pause to reflect on how this works. Human civilizations today build terraces on mountains, dig canals across plains, and straighten rivers. These structures, seen from above, alter the flow of water and soil. If left untended, they erode and collapse, but sometimes their shapes endure for thousands of years. A ridge may carry the memory of a wall. A field may echo the lines of cultivation. From the ground, these features seem ordinary. From the sky, they reveal geometry. Let us linger here and extend the thought into deep time. If civilizations before the dinosaurs shaped their environments, their works would not survive as stone monuments. Instead, their influence might appear as unusual landforms, patterns of soil movement, or drainage that does not align with natural processes. Yet we must be cautious. Nature itself creates patterns that can look geometric: hexagonal basalt columns, polygonal cracks in drying mud, the braided lines of rivers. Distinguishing natural order from intentional design is difficult, especially when hundreds of millions of years have passed. Now we may soften our focus to the language of traces. Remote sensing today reveals ancient human activity otherwise invisible. buried cities outlined by crop marks, forgotten roads traced by subtle ridges. If we imagine similar methods applied to deep geological history, we might search for alignments or shapes that resist easy natural explanations. But the deeper we go, the more time erases. Uplift reshapes surfaces, erosion smooths edges, glaciers scour plains. The original signal dissolves, leaving only faint and ambiguous hints. Let us try a gentle thought experiment. Imagine first a civilization that reworks a vast floodplain, carving canals in straight lines, building terraces that control the flow of water. Step further. The civilization ends, the canals silt up, the terraces collapse, vegetation returns. Step again. Millions of years pass, rivers meander, but some traces of the old channels still guide their flow. Step once more. Hundreds of millions of years later, geologists study the valley. They see odd straight alignments in the sediments, patterns not typical of natural drainage. They consider tectonic faults, ancient glaciers, or chance. The possibility of intention does not occur, for the civilization is long forgotten. This experiment shows us how landscapes can carry memory, but only in distorted forms. Before moving on, let us rest with the humility this brings. Patterns are not proofs. They are suggestions, easily shaped by imagination. Seeing design in nature is tempting, but without context it remains uncertain. Science teaches us to weigh possibilities, to compare, and to admit when we cannot know. And so we arrive at a quiet conclusion. Landscapes may hold whispers of past civilizations, but they are among the most fragile and ambiguous of signals. What looks like geometry may be coincidence. What seems like intention may be the work of rivers or ice. The Earth's surface changes too often to preserve clear lines. Still, the thought encourages us to look differently, to see that the world around us is layered with stories, some natural, some cultural, and many lost in the blur between the two. In this awareness, we find both wonder and patience, listening gently to the shapes of the land as though they were part of the planet's own memory. What if the only true relics of ancient civilizations, if they ever lived before the age of dinosaurs, are not objects at all, but the extinctions they left behind? Life, when disturbed on a grand scale, reacts in patterns we can sometimes read in the fossil record. These patterns are quiet but clear: sudden losses of diversity, gaps in the tree of life, abrupt shifts in which species dominate. They are not monuments in stone, but absences in biology, voids that tell of events we may never fully understand. Now we may pause to reflect on how extinctions are seen in deep time. Fossil layers show us when one group of organisms disappears and another takes its place. Usually, this is gradual, a slow turnover as climates shift and environments change. But sometimes the transition is sharp, compressed into a thin layer of rock. At these boundaries, we see mass extinctions, the end Permian, the end Cretaceous, moments when much of life was lost in what seems like an instant. The usual explanations are vast volcanic eruptions, asteroid impacts, or climate shocks. Yet, if civilizations had once flourished and then collapsed, they too might leave traces that resemble these sudden breaks. Let us linger on the language of traces. Extinctions show themselves in statistics, in counts of fossils above and below a boundary. They also appear in chemistry, as sudden rises in carbon dioxide or methane, or in ash deposits scattered through sediments. These signals are ambiguous, for natural and cultural causes might look the same. A mass burning of forests could reflect a vast volcanic event or the actions of an intelligent species altering its environment. We cannot be sure. Now we may try a gentle thought experiment. Imagine first a civilization expanding across the world hundreds of millions of years ago. It hunts, farms, and reshapes ecosystems, driving many species to extinction. Step further. Its industries release gases, its activities burn landscapes. The air shifts, the oceans warm, and more species vanish. Step again. The civilization itself collapses, its traces erased by time.
But the extinctions remain, recorded in the rocks. A sudden loss of diversity, a chemical anomaly, an empty layer in the fossil record. Step once more. Scientists in the far future study this layer. They debate whether it was a volcanic winter, an asteroid strike, or something else. The civilization is gone, but the echo of its presence lingers in the silence of vanished species. Before moving forward, let us pause with the humility this invites. We cannot know with certainty the causes of every extinction. The deeper we look into time, the fainter the signals become, the more blurred the boundaries between nature and possible culture. What we do know is that life is sensitive to disturbance, and when something large enough happens, the loss is written into the record. And so we arrive at a quiet conclusion. If civilizations existed before the dinosaurs, their clearest legacy might not be what they built, but what they destroyed. Extinctions, preserved in stone, outlast monuments, outlast memory, and whisper of disruptions beyond the ordinary. Whether those disruptions were natural or cultural, we cannot say. But in the silence of species that vanished, we hear the faintest possibility of civilizations lost, dissolved into the deep time of the earth. What if the traces of ancient civilizations, if they once arose before the dinosaurs, are hidden not in grand patterns, but in the smallest of things? Microscopic residues, mineral inclusions, or tiny anomalies in layers of earth. These would not be monuments or artifacts as we usually imagine them, but quiet particles, so small we would only notice them under careful study. Now we may pause to think about what the microscopic world preserves. Grains of pollen trapped in sediments tell us about ancient forests. Layers of volcanic ash carry crystals that reveal the chemistry of eruptions. Even fragments of dust falling from space can be found in deep-sea clays, preserved for millions of years. The small often endures where the large does not, for it weathers into the background, overlooked and therefore protected. Let us linger on how this might apply to civilizations. If they once burned fuel, the ash could have settled into sediments as unusual microscopic particles. If they mined or smelted metals, the waste might have been captured as tiny spheres of slag, mixed invisibly into soil and later buried. Even glass created by intense heat, natural or artificial, can survive as droplets called microtectites, scattered across continents. To us, they look like the products of impacts or volcanoes. But in theory, they could also be the fading fingerprints of technologies now lost. Now we should rest for a moment with the limits of our knowledge. Natural processes are vast and varied. Lightning makes glass and sand. Volcanoes scatter ash across oceans, and meteors create spheres of molten rock that harden as they fall. Distinguishing natural from cultural particles is nearly impossible when hundreds of millions of years have passed. Science leans toward natural explanations, not from denial, but from caution, for extraordinary claims require extraordinary evidence. Still, the possibility reminds us to look closely, even at what seems ordinary. Let us try a gentle thought experiment. Imagine first a civilization that spreads across a continent, building, burning, and mining. Step further, its activities release ash and metal dust, fine particles that drift on the wind and settle in lakes and seas. Step again, the civilization fades, its cities crumble, its monuments vanish, but the particles remain, sealed in layers of clay and stone. Step once more, hundreds of millions of years later, a scientist studies these layers. Under a microscope, she finds strange spheres, odd crystals, unusual chemistry. She considers volcanoes, meteor impacts, or chance. The thought of civilization never enters her mind. The signal is there, but its story is lost. Now then,
Us note, before moving further, that science thrives on such puzzles. Every unexplained anomaly invites further study. Most turn out to have natural causes, but the very act of looking reminds us that the Earth's record is filled with mysteries, some solved, some not. And so we come to a quiet conclusion. Microscopic residues may be among the most durable markers of civilizations, but they are also the most ambiguous. They survive where cities do not, yet they dissolve into the great chorus of natural processes, almost indistinguishable from what volcanoes, impacts, or fires would create. The possibility is there, but the certainty is not. In this uncertainty, we are reminded of humility and of the patience required to read a planet's memory written in particles smaller than grains of sand. What if the only real evidence of ancient civilizations, if they ever existed long before the dinosaurs, is not what they created, but what they discarded, their waste, their byproducts, their leftovers quietly folded into the Earth's deep archives? When we think of ruins, we imagine temples and cities. Yet often, what endures more stubbornly is trash, broken tools, burned fragments, layers of refuse. In our own time, landfills hold more of our story than monuments will. Perhaps the same could be true for any forgotten worlds. Now we may pause with how waste becomes part of the record. Everyday debris, if buried quickly, can fossilize like bones. Ash from fires can settle in sediments, sealing dark layers that endure for millions of years. Even substances we think of as fleeting, like soot or oil residues, can leave thin chemical fingerprints in soils and rocks. The Earth is patient, and it transforms what is thrown away into quiet pages of its geological diary. Let us linger with the thought that waste is not only physical, it can also be chemical. In our era, we release plastics, pesticides, and synthetic molecules into air, water, and soil. Many of these will break down slowly, but traces may remain in sediments far into the future. Radioactive isotopes, too, spread by industry or weapons, will mark our age with signals that nature alone does not produce. If civilizations before us had their own materials, even if unlike ours, their chemical shadows might linger in the same way. Yet here we must acknowledge the limits. Natural processes also leave strange residues. Forest fires scatter soot, volcanoes release heavy metals, and meteor impacts distribute rare elements across continents. To separate the cultural from the natural requires careful comparison, and even then, certainty is often out of reach. Absence of proof does not mean absence of presence. Now we may soften our focus with a gentle thought experiment. Imagine first a civilization that flourishes deep in time. It makes tools, burns fuels, leaves waste. Step further, over centuries, debris accumulates, settling into soils, washed into rivers, buried in sediments. Step again, the civilization vanishes, buildings fall, tools crumble, but the waste, ash, soot, residues remains, layered quietly into the earth. Step once more. Hundreds of millions of years later, scientists dig and drill. They find thin, dark bands of soot, unusual clusters of metals, faint chemical anomalies. They interpret volcanic activity, asteroid strikes, or fires. The thought of civilization never arises. The waste remains, but its meaning dissolves. This experiment shows us how fragile the connection is between cause and trace. The traces can survive, yet their story may not. Now we may rest with the reminder that science is cautious, because it must be. The deeper into time we look, the more signals blur, the more natural and cultural causes overlap. What remains is ambiguity, and within that ambiguity lies both frustration and wonder. And so we come to a quiet conclusion. Waste, though mundane, may be the most enduring evidence any civilization leaves behind. But in the silence of deep time, its meaning becomes uncertain, absorbed into the vast cycles of geology. If others lived before the dinosaurs, perhaps their legacy is hidden not in monuments, but in anonymous residues, indistinguishable from the byproducts of nature. We cannot know for sure, yet in reflecting on this possibility, we learn to see our own traces differently, with both humility and calm awareness of how the earth remembers. What if the deepest memory of civilizations that may have existed before the age of dinosaurs is not held by the ground beneath us, but by the oceans? The seas cover most of our planet, and their sediments build steadily over time, like pages pressed together in a book without end. These sediments capture not only the remains of life, but also the byproducts of change: ashes, metals, chemicals, and organic matter drifting down, settling quietly into layers. The ocean floor is, in this sense, the planet's vast archive. Now let us pause to see how these records form. Tiny shells of plankton rain down after death, carrying with them the chemistry of the seawater in which they lived. Dust from continents, soot from fires, and particles from volcanoes sink alongside them. Over thousands of years, these materials form sediments that harden into stone. When drilled today, they reveal histories of temperature, oxygen, and carbon that stretch back tens of millions of years. If civilizations had once disturbed the oceans or the air above them, perhaps their echoes lie buried here as well. Yet we must soften this thought with the limits of time. The ocean floor is not permanent. It is born at mid-ocean ridges and recycled back into the mantle at subduction zones. On average, the oldest ocean crust is about 200 million years old. Anything older than that is lost, melted, erased. Civilizations before the dinosaurs would have lived far earlier, and their seafloor traces, if any existed, are now gone. What remains are only fragments near shorelines where ancient seabeds were lifted into mountains. These too are weathered and incomplete. Still, even in their incompleteness, the seas remind us of how powerfully they record. Now we may linger with the language of traces they might hold. Sudden increases in certain metals could suggest mining runoff. Shifts in isotopes of carbon or nitrogen could mark unusual inputs from agriculture or fuel burning. Layers rich in soot could hint at widespread fires. To us, such signals are more readily explained by volcanoes, by impacts, by natural cycles. Yet the possibility remains that some of these unexplained anomalies were shaped, in part, by cultural hands long forgotten. Let us try a gentle thought experiment. Imagine first a civilization that reaches across coasts and rivers, using the sea for travel and food. Step further, its industries release metals and chemicals into the water. Waste drifts out to sea, carried by rivers, settling into sediments layer by layer. Step again. The civilization ends, erased by catastrophe or time. The seas continue their cycles, covering the traces with new sediments. Step once more. Millions of years later, scientists drill into stone that was once seabed. They find chemical anomalies, thin black bands of soot, odd distributions of metals. They conclude volcanic eruptions, or impacts, or chance. The civilization story is lost, its traces hidden in the ocean's patient record. This experiment reminds us of the difficulty of interpretation. Oceans keep memories, but they blur them, mix them, and fold them into other rhythms. The signals endure, but their meaning drifts away. Before we move further, let us pause with humility. The seas have been both cradle and archive for life, but they are not generous with clarity. Their records are partial, their stories disguised. What they keep is not narrative, but fragments, waiting to be pieced together with care. And so we come to a quiet conclusion. If civilizations once existed before the dinosaurs, their traces may lie not on land, but within ancient seabeds, folded now into mountains or dissolved back into the earth. Oceans hold the memory of change, but they speak in whispers, in chemistry and sediment, not in monuments. We cannot know if they carry echoes of civilizations before us, yet,
in reflecting on this, we gain a wider view of time and of the patient, endless work of the seas as keepers of the planet's memory. What if the atmosphere itself, that vast and shifting envelope of gases around the Earth, has carried the faint memories of civilizations far older than our own? Air seems transient, invisible, always moving, but in truth, it holds a record of change. Its composition responds to what life does, to what volcanoes release, to what oceans absorb, and to what civilizations, if they ever existed, might have added or taken away. Now we may pause to think about how the air is stored in time. While the atmosphere itself does not fossilize, its chemical story is captured indirectly. Snow falling on polar regions traps bubbles of air, sealing them in ice. Over thousands of years, these layers build, preserving ancient atmospheres like tiny glass cases. Sediments in oceans also lock in signals of air through the chemistry of shells and minerals. Even certain rocks, formed in contact with the air, retain chemical signatures that whisper of past climates and compositions. Let us linger with the mechanisms behind these signals. Carbon dioxide, for instance, rises when forests burn or when fuel is consumed. Methane increases with wetlands, with ruminant animals, or with industry.
Oxygen levels shift with both natural cycles and with large-scale activity. Each gas leaves its trace in sediments, ice, or minerals, waiting to be measured long after the original event. If civilizations before the dinosaurs had changed their air, the signals might remain, not as words, but as altered balances of gases. Yet we must pause again with the limits of knowledge. Natural processes are powerful and frequent. Volcanoes, meteor impacts, ice ages, and ocean changes have all shifted the atmosphere many times. The same signals that might suggest civilization could also come from these forces. And because records older than a few million years are scarce, anything before the dinosaurs is blurred almost beyond recognition. The possibility is there, but it hides in ambiguity. Now let us try a gentle thought experiment. Imagine first a civilization that flourishes long before the age of reptiles. It burns fuels, clears landscapes, changes the balance of its air. Step further. Snow falls on remote peaks, trapping bubbles of this altered atmosphere. Oceans absorb the gases, locking them into sediments. Step again. The civilization vanishes, erased by time. But the atmosphere it changed leaves chemical echoes sealed in stone and ice. Step once more. Millions of years later, scientists drill deep into ice or rock. They measure unusual levels of carbon or methane, anomalies that do not align with volcanic cycles. They wonder at the cause. The civilization's story is gone, yet the breath of its world lingers faintly, coded in chemistry. This experiment shows us how the atmosphere itself could serve as an archive. It records change faithfully, but not its source. Interpreting the signals requires caution, for air responds to both life and disaster alike. Before we move on, let us pause to note the humility in this search. We look for certainty, but often we find only patterns that could mean many things. Absence of clear evidence is not evidence of absence, but it is a reminder of how fragile memory becomes when measured in millions of years. And so we arrive at a quiet conclusion. The atmosphere, though invisible, is a recorder of change, a witness to what life and perhaps civilizations have done. If others lived before us, they may have altered their air, leaving faint traces in the Earth's chemical layers. Whether those traces survive is uncertain, but the very act of considering them reminds us of how deeply the air connects to all life, and how it carries, however briefly, the imprint of those who breathe within it. What if the most enduring traces of civilizations that might have risen before the dinosaurs are not the materials they shaped, but the energy they used? Energy leaves its mark in ways subtle,
yet profound. When consumed on a large scale, it alters balances in air, water, and soil, shifting the planet's cycles in ways that can last long after the tools themselves vanish. We may pause here with the thought that every civilization depends on harnessing energy. For us, it is fire, coal, oil, and electricity. For earlier life, it may have been sunlight stored in plants or heat drawn from the earth. If civilizations long before the dinosaurs ever existed, they too would have needed to control energy to thrive. This use would not have disappeared without consequence. It would have left signals, faint but real, written in chemistry and sediments. Now let us linger with the processes behind such marks. Burning fuels releases carbon dioxide, which shifts the balance of isotopes in the atmosphere. Clearing landscapes alters the carbon stored in soils. Extracting metals or minerals leaves chemical scars in sediments. These effects may not appear as monuments, but they can be read as changes in global patterns. Ice cores, though limited in age, show how our own activities have already transformed the atmosphere. If the past held other cycles of energy use, their chemical fingerprints might also exist, buried deeper in rocks and layers. Yet here we must soften
our expectations with humility. Natural processes can mimic these same signals. Volcanic eruptions release carbon and metals. Meteor impacts scatter unusual elements. Even the slow breath of oceans, absorbing and releasing gases, can create anomalies that resemble industrial influence. Distinguishing between cultural and natural causes is delicate, and the further we look into time, the less certainty we can hold. Now let us try a gentle thought experiment. Imagine first a civilization emerging in a warm and fertile age hundreds of millions of years ago. It learns to burn fuels, to reshape its environment, to release energy on a scale beyond what life alone would do. Step further. The gases rise, the balance of air changes, soils are altered, oceans shift their chemistry. The civilization collapses, erased by time, yet the changes it made linger in sediments. Step again. Millions of years pass. Geologists study these layers, noting a sudden spike in carbon, a strange imbalance in metals, an unexplained anomaly. They assign it to volcanic eruptions, for no other explanation is at hand. Step once more. The story of the civilization is lost, yet its use of energy is still faintly written in the planet's memory. This experiment shows us that energy leaves marks not in stone walls, but in cycles of Earth itself. Before moving further, let us pause to consider our own position in this reflection. We too leave chemical signals in the atmosphere, the oceans, and the soils. Future scientists, millions of years from now, might see our traces as nothing more than anomalies, uncertain in origin. In this way, our imagination of ancient civilizations also teaches us how our own story may be read, or misread, by those who come after. And so we arrive at a quiet conclusion. Energy, though intangible, may be one of the most lasting markers of civilizations. It changes balances that endure long after buildings crumble. If others existed before the dinosaurs, their presence may be encoded in these subtle shifts, blurred now by natural cycles, but never entirely erased. We cannot say with certainty, but we can listen for the faint hum of energy in the geological record, a whisper of possibility carried across deep time. Known rhythms. When climatologists reconstruct temperatures from minerals, they expect smooth variations that fit orbital cycles. Yet sometimes, the data show abrupt, unexplained breaks. These breaks can be signs of catastrophe, but they could also, in theory, be shadows of civilizations altering their world. Let us linger with the simple example. If a layer of rock shows a sudden, sharp rise in carbon dioxide, we may interpret it as volcanic eruptions. But if the rise is followed by a plateau, as if held there for centuries, the pattern differs from natural events. Or if nitrogen isotopes in soils show fluctuations that match no known climate cycle, they may hint at changes in ecosystems not caused by weather alone. The numbers, in these cases, act like whispers, never shouting, but suggesting that something unusual took place. Yet here we must pause again with humility. Data in deep time is incomplete. Fossil counts are uneven because preservation is uneven. Isotope records are blurred because sediments mix over time. Statistical signals may seem significant, but may vanish when more data is added. The risk of seeing patterns where none exist is real. Still, the search teaches us to listen carefully, not just to objects,
but to the rhythm of numbers themselves. Now let us try a gentle thought experiment. Imagine first a civilization spreading across a continent, reshaping landscapes, altering climate. Its activity pushes carbon dioxide higher, disrupts soils, changes rivers. Step further. Over centuries, these effects create patterns. Plateaus where there should be rises, fluctuations where there should be smooth cycles. Step again. The civilization disappears, erased by time. But the statistical irregularities remain, sealed in stone, in isotope ratios, in fossil counts. Step once more. Millions of years later, scientists collect the data. They chart graphs, puzzled by anomalies that defy known natural causes. They discuss rare volcanism, meteor impacts, chance. The thought of civilization does not arise. The numbers speak, but their language is misunderstood. This experiment shows us how patterns can outlast things. Objects crumble, but statistical irregularities, once encoded in the record, endure. Before moving further, let us rest with the thought that patterns are among the most fragile, yet most resilient forms of evidence. They are fragile because they can be erased by noise or by lack of data. They are resilient because once written across scales of the planet, they cannot be fully undone. They remain, waiting for interpretation. And so we come to a quiet conclusion. If civilizations existed before the dinosaurs, their most enduring traces might be anomalies hidden in the mathematics of the Earth, patterns in chemistry, biology, and climate that do not align with natural cycles. We cannot prove such origins. We can only acknowledge the possibility that within the rhythm of numbers, faint signals may still linger, reminding us that even lost stories can echo through the language of patterns. What if the most revealing traces of civilizations that may have existed before the dinosaurs are not hidden in the ground at all, but within the stars above us? Our planet is not isolated. It is part of a wider system, bathed in radiation, struck by particles, and influenced by cosmic rhythms. If civilizations long ago learned to use energy on scales greater than the Earth itself, perhaps their echoes are written in the sky, in signals that blend with natural starlight and cosmic noise. Now let us pause with the idea of the cosmos as an archive. Light travels for immense spans of time, carrying information about what once occurred. Radiation, too, leaves its imprint, absorbed in rocks, stored in isotopes, measured in cosmic ray traces. Some researchers speak of technosignatures, faint signals that suggest artificial origin. These could include unusual radio emissions, unexplained concentrations of isotopes, or disturbances in orbital mechanics. If ancient civilizations had ever reached beyond their home, such traces might endure in space,
far longer than on the fragile surface of Earth. Let us linger for a moment on the processes behind such records. When a civilization uses great energy, it can produce heat and radiation. When it explores beyond its world, it may leave objects in orbit or on moons or in the asteroid belt. These objects, if left adrift, could circle for millions of years, immune to erosion. Cosmic rays, when interacting with technology, may leave isotopic scars that we could still measure today. None of these signals are certain, yet the possibility lingers quietly, like a faint background hum. But now we must soften our gaze with humility. Space is vast, and natural signals are many. Pulsars, quasars, and magnetic storms create noise that drowns faint whispers. Orbits are not eternal, and objects eventually collide or fall. Even isotopes on Earth, though formed by cosmic events, can be difficult to distinguish from natural causes. The absence of clear proof is not proof of absence, yet it reminds us of the difficulty of searching for shadows in the sky. Now, let us attempt a gentle thought experiment. Imagine first a civilization older than the first reptiles, lifting its eyes to the stars. It builds machines that harness energy, perhaps sending them into orbit or beyond. Step further. These machines circle their world for centuries, then are abandoned, drifting silently through space. Step again. The civilization fades, its world reshaped by time, its surface scoured clean. But in orbit, a handful of objects remain, circling, eroding slowly, still reflecting faint glimmers of starlight. Step once more. Millions of years later, another species rises. They study the sky, noticing odd reflections, peculiar orbital patterns, slight anomalies in radiation. They assume they are natural. The story of the earlier civilization is not recovered, yet its echo lingers in the sky, faint but persistent. This experiment shows us how space may preserve what Earth erases. While oceans recycle and rocks weather, the heavens keep fragments in motion far longer. Before moving on, let us rest briefly with this thought. The stars are not only distant, they are mirrors, reflecting possibilities of stories beyond our own. We cannot read them clearly, but their silence is not proof that they hold no memory. And so we come to a quiet conclusion. If civilizations lived before the dinosaurs, and if they reached beyond their planet, their most lasting traces may be among the stars. Tiny signals, forgotten objects, subtle shifts, faint but enduring. We may never be able to separate them from the vast background of nature, but in imagining them, we glimpse how fragile and how resilient traces of intelligence can be. The cosmos, with its endless patience, may carry whispers longer than the Earth itself. What if the greatest lesson of imagining civilizations before the dinosaurs is not whether they truly existed, but how their possibility reshapes our sense of time? Time, in the geological sense, is almost beyond grasp. Millions of years pass as easily as seasons do for us, and hundreds of millions stretch out like the slow breathing of the Earth itself. Against this scale, even the rise and fall of whole civilizations, our own included, would be like ripples fading quickly on the surface of a vast ocean. Now, let us pause with the idea of perspective. When we study ancient layers, we search for continuity, for traces that connect one age to another. Yet, the possibility of earlier civilizations reminds us that what we see is always partial. The archive is broken, the pages of Earth's book are missing, torn, or rewritten. What lies between the chapters may be more than silence. It may be stories erased almost completely. If we allow ourselves this thought, we begin to see that uncertainty is not weakness, but a natural condition of deep time knowledge. Let us linger with how we reach conclusions in such a landscape. We measure isotopes, count fossils, trace sediments. We compare patterns to what we know of natural cycles, volcanoes, impacts, ice ages, extinctions. And yet, even with this rigor, we admit what
cannot be answered fully. The absence of clear evidence for pre-dinosaur civilizations does not close the question. It simply sets it aside, as a page not yet discovered. This humility is itself a form of knowledge, a reminder that science, too, is shaped by what it cannot yet touch. Now let us try a gentle thought experiment. Imagine first that ancient civilizations did exist. Their traces are buried, erased, folded back into the mantle, recycled by oceans, scattered by erosion. Step further. All that remains are faint signals, odd chemical spikes, unexplained anomalies in climate cycles, subtle irregularities in biodiversity. Step again. We discover these signals, but we cannot decode them. We explain them as natural, for that is what fits. Step once more. The story is not recovered, but the possibility of it lingers, reminding us of the fragility of all records. And now imagine the alternative. Suppose there were never such civilizations. Suppose we are the first. Even then, the act of imagining others gives us perspective on our own place. It shows us how fleeting our impact may be, how even great change is swallowed by time. Whether others came before or not, the lesson is the same. Civilizations are small against the patience of the earth. Before we move to rest, let us pause with the language of traces. Stones, sediments, isotopes, stars, all are archives, but none are perfect. They hold whispers, not declarations. They allow us to listen, not to know with final certainty. The universe does not offer us answers in clear lines, only in faint signals and possibilities. And so we arrive at a quiet conclusion. Perhaps civilizations before the dinosaurs never existed. Perhaps they did. Either way, the thought expands our sense of scale. It softens our certainty. It places us not at the center of history, but as part of a vast and ongoing rhythm. Time is long, the earth is patient, and our stories, like all stories, are fragile threads within it. If we are drawn to this rhythm, if we find calm in its quiet unfolding, then we already know how to continue.